Welcome to the very first episode of the Alchemist Podcast. Today we are joined by Arpan Mate, the founder of Alchemist and Alchemist, two brands leading a new era where interior design meets innovation in the UAE. From luxury fit-outs to large-scale robotic 3D printing, Arpan's journey is a fascinating blend of creativity, craftsmanship, and technology. Arpan, welcome to the show.
Thank you very much. It's really great to be here on the podcast. I'm really excited to share what we have been building at Alchemist all this time and how the overall idea has evolved with time.
For those who are new to Alchemist, can you tell us a bit more about what the company does and how it all started?
Sure. Alchemist began as a full turnkey solutions company here in UAE. We deal in all kinds of interior fit out and renovation projects ranging from commercials and residential, which comprises of villas, apartments, offices, and much more. So the idea was pretty simple, combining craftsmanship, in-house design, and seamless project execution. And to be honest, it was never about just doing fit outs. It was about disrupting the way the fit outs have been done in today's time.
Alchemist started strong in fit outs and interior design. What inspired the move into 3D printing and additive manufacturing?
So, construction and interior industries are few of those industries which are the slowest to adopt the cutting edge technologies, the latest technologies used as robotic fabrication, digital manufacturing. Digital manufacturing has been there, but there is still a limited adoption which has happened. While if we see many other industries, I would say one of the most famous is the automotive industries, where the automation is at very next level. And looking at that slow adoption, we want to change that. So I believe that the design shouldn't be limited by what's possible today. Rather, it should be more about how can we push the boundaries and break those stereotypes of doing the fabrications. In interiors and design, we often have creative limits because we want to achieve a complex shape and complex geometries and forms which are again limited by the current workflows. Then that's where the additive manufacturing, the large scale robotic 3D printing comes in place. So the idea was to merge art, computational design and robotic workflows through which we can achieve complex forms, geometries, shapes and textures, which is usually not possible through the traditional ways of fabrication. And that's where the large-scale 3D printing comes in place. And which is why we got interested into this. And it's a passion. And that's where we created our own ecosystem of robotic 3D printing, which comprises of a robotic arm, our custom-made extruders. By the way, we have a couple of iterations, and our own ecosystems of palette-based robotic 3D printing technology. And that's how the Alchemist, our innovation arm of Alchemist, was born.
How do you see 3D printing changing the way we design and build spaces, especially in interiors and architecture?
So it's a complete shift in the mindset, in the way the design and construction has been done. It was, and until today, it's still focused on mass production, rather mass customization. So this robotic 3D printing process gives us the power to go towards mass customization, where every element of a product, most of the decor items like wall panels, light fittings, furnitures and all are customized specifically for that particular space, which kind of stitches to the story of the client, the workflows of the client. And that's where the power lies. For architects and designers, this opens a completely new chapter, because we are pushing the boundaries using this technology of what's possible, using the conventional ways, and which enables us to fabricate much more complex shapes and forms, as I mentioned earlier. It also makes the overall fabrication process more efficient, where the material wastage is almost negligible, and the overall time durations also shrink down drastically. For example, if we talk about the joinery product and we cleverly design a product which might be a fuse of joinery and 3D printing, or just 3D printed product like a furniture, it drops down from weeks to days, or from days to hours. To me, that's the future of interiors.
You have introduced beautiful 3D printed pieces like the lamps, vases, and planters. Can you tell us more about how those products came to life?
All our product, our 3D printed product, actually started as experiments, exploring the curves, the geometries, and diving with curiosity into it. One thing I would like to highlight is it was a teamwork, and the team had a synergy. The team of design and fabrication did a lot of testings, first sketches, then it went for initial models, prototyping, connection details, failures, which kind of reinforced us and helped us to lead the path further. So that's where this, like again, as I mentioned, it was a great synergy, and that's how we were able to convert the all the experiment sketches into a living product. I'll show you something. This particular product, for example, is from the family Bloom. Our products are divided into different families, and then family-wise, there are a couple of different products for specific usage. This one is inspired from a blooming flower. So if you can see this curve, the way the flower starts to open at the initial stages, this is inspired from that. And as I mentioned, the experiments, we had a lot of experiments done on how the connection details can happen. So as you can see here, this has a base, this has a shell. The shell, it cannot be a full product for usage practicality, and that's where the snap-in mechanism comes in place.
Now let's talk about the process. What kind of technology and materials go into making these 3D printed designs?
Our process is based on one core principle. We took the hard path. We wanted control over the technology we use. Why? Because as we do experiments and we evolve our processes with time, we want control that we can tweak, adapt, and develop our equipments and machineries and tools according to our usages, rather than having the dependencies for downtime or for expansion and things. So our overall ecosystems has a center part, which is the core component, is the robotic arm, which is procured from KUKA. But then rest everything which is used in this process, such as extruders, heat bed, and material systems and all, most of it is engineered in-house or has been upgraded in-house as per our usage. The main component is the extruder, which gets the material feeded, and which has a heating component, and it melts the polymer, and that's where we get that flow coming out from the machine. So that we have 3 iterations. 2 of them are completely engineered in-house, and 1 is an upgrade of the off-the-shelf extruders available in the market. Then we talk about heated bed. Also, we have engineered heated bed is something which is not very much crucial for the 3D printing processes in the large scale because of the scale we talk about, but we felt the need when we explored different materials. Different materials have different challenges, which is why we engineered it, and we have a heated bed in-house. Material wise, we use pallet based extrusion because when we go in large scale, using the filament doesn't make sense at all because of the higher volume. The printing time needs to be drastically cut down for ample of reasons, and that's where the palette based always has a superiority on that. And we have more control on colors. For example, we use a separate component called master batch. These are color pigments which we add before every print depending on what color we want. There are pre-colored PETG palettes also which are available, but we specifically use to get more control of having the base same and using the colors separately and dosing them just before the print. And to be more precise in what type of material we use PETG. It is a kind of a variant of PET. It has more flexibility and structural strength as compared to PET and less brittleness. And we use rPET, which is a recycled version of PET. And with time, we are going to add more materials to our workflows. And in overall, our entire stack, as I mentioned, comprises of different components. Most of them have been engineered in-house and are regularly evolving. For example, our extruders are planned to have some more sensors in future where we would be able to test pressure for the flow, which will give us more precise parameters for how much tweaking we need, and then we would be able to get much more fine and much more, I would say, homogeneous extrusions.
Customization seems to be a big part of your approach. How do you work with clients who want something unique, whether it's a fit out element or a product?
Every client and every space tells a different story. So our target is, we call it information gathering. So we hear out the client, understand their requirements, stitch them together, put it in a mood board. From there we get an intent of our design that gets fed, and that's where the design starts. We use conventional design process plus computational designing, because having computational designing in every process is also overkill. So for us, time balance has to be very efficient, and that's where, when we talk about an element or a product where it makes sense, we implement our computational designing processes. But computational design most of the time has a superiority over conventional designing processes, where the decision making can be faster. So I'll give you a use case here. If I'm designing a chair, I can have a lot of iterations of that chair in a very short duration of time, which gives the client freedom to choose from multiple choices, and of course, and implementing different textures and experiment many things, rather than if we do it with conventional designing, you have to either make it from scratch or put a lot of time in tweaking the models and stuff. So that's where the superiority comes in place. And the whole design process is done taking into consideration the technical factors of the fabrication process we do, that is the 3D printing process. And then when we jump on to the fabrication process, the client has the freedom to choose their materials, glossy, matte, colors, and more factors to choose from. And the process is fast, as I mentioned, as compared to the traditional ways of fabrication. In the end, every product we do is unique, tailored for that space, specifically as per their usage and functionality.
Can you tell us a bit more about how do the 3D printing capabilities complement your fit-out projects? Are we going to see more custom 3D printed elements in future interiors?
Of course, we just got started. So I'll just tell you I always like to tell by real life scenarios, that is the use cases. So we have a couple of projects. I'll tell you a recent project we delivered was a full turnkey project. From there, specific element was a landscaping feature wall, we called it. It was exactly on the entrance of the villa. And the client's requirement were simple. They wanted a planter area, but same time it to be a feature, a point of attraction, where multiple plants can go. The space was limited. It was supposed to be on adjacent to a boundary wall. So what we have a back wall which has multiple planters in different shapes separately, which can be staggered in different location, but same time, if you put them and stack them, they become one geometry. And that's where again the power of computational designing comes in place. We have like 6 to 8 planters, I would say six planters stacked together, fabricated using our robotic workflow, 3D printing workflow. And it was a hit. Client really loved it. You can see and check it out on our website and our Instagram profile. I can tell you one more use case scenario to you. It's an ongoing project right now. It's an apartment project, our turnkey project. The client's requirements were very specific. They didn't like the chairs which are available in the market. They wanted something unique which can be fabricated specifically for them, and that's where our process comes in place. We gave them the iterations for different chairs. They need 2 armchairs, dining chairs, and some chairs for the externals to sit outside. And you can see some good insights about that project very soon. So again, answering to your question, definitely you're going to see a lot of very exciting deliveries for custom elements or projects specifically using our 3D printing workflows. We have a lot of interesting and exciting projects and products coming up.
What has been the most exciting or challenging part of integrating 3D printing into your workflow?
I mean, it has been both exciting and challenging. I mean, it's a passion, as I mentioned, and challenging because, as I told you earlier, we took the hard path. we wanted the control over the technologies what we use, and that's where the R&Ds came in place. Just before diving into the design parameters and factors only, we dived into the hardwares and made the overall ecosystem functioning around us. And that's the functioning part. I just said it in few seconds, but it really took a lot of time, a lot of failures of days and months, and it was frustrating. But again, a huge shout out to the team. The design and specifically the fabrication team never gave up. We did hundreds of tests where every print failed, but every print gives us a direction of where we should go and improvise, and that's how we are what we're right now.
3D printing often gets linked with sustainability and efficiency. How does Alchemist approach responsible design and production?
For us, sustainability isn't just a marketing angle, it's about how we design and produce. So going with more smarter, efficient designs where we use the right amount of material, not much, not less, what is required, engineered properly. And then when we go to the fabrication side, reducing the wastage. I mean, zero wastage is kind of, I would say, not myth, but still we are not there in the technology. There is very slight amount of wastage which goes in slight testings and all, which again we try to recycle. Then using smarter materials with respect to the sustainability, like our PET, we are using a recycled PET for one of our workflows, and that's where the sustainability comes in place. And even if we have some wastage from it, we can get it recycled from the local supplier itself. So designing locally, producing locally, and trying to reduce as much as wastage of materials.
So what's next for Alchemist, both in fit-out and in additive manufacturing?
So from the overall until now, I'm sure you got it that Alchemist has mainly two arms, two branches. One is the interior, which is growing all over UAE, giving turnkey solutions for different kinds of projects, residential, commercials. And our innovation side, that is Alchemist, is diving deep into the robotic manufacturing process and innovation and materials, where we provide different kinds of products and services such as custom decor solutions, and also, by the way, you can also go on our website and check out our shop where you can straight away order some products over there. Really cool products you must check out. So the goal is to make advanced design and fabrication accessible. Either you're an architect or an interior designer or a B2B or a B2C client, individual clients. If you want something unique, you're looking for a seamless experience, quick deliveries, and something really, really state of the art, we are the right place. Ultimately, the vision is pretty clear. We want to merge art, craftsmanship, and seamless experience for our clients.
Thank you, Arpan, for sharing the story behind Alchemist. It is truly inspiring to see how design, robotics, and sustainability intersect to reshape interior spaces.
Thank you very much. It's been really a pleasure being here.